Hello boys and girls, welcome to lesson 3-2, slope. In this lesson we're going to continue to address the question, why are graphs helpful? And our vocabulary will be slope, rise, and run. Let's explore the vocabulary by doing this vocabulary startup activity. The term slope is used to describe the steepness of a straight line. Slope is the ratio of the rise, or vertical change, to the run, or horizontal change. So rise over run. I think this word means, so what does the word slope mean to you? Well, to me it means downward or a slant. How is this concept related to other math concepts? Well, we've learned earlier in the year about ratios. And a slope is determined by a ratio. So it is a ratio. Where have I heard this word in my life? Well, I've heard it to describe a roof, right? Like a very slanted roof, or a roof with a strong slope, or even a hillside. And finally, when considering the word slope, what makes this an important word for me to know? Why do I need to know the word slope? Well, I would say so I can describe the steepness of a straight line, or so that I can see how amounts change over time. If we are able to analyze the slope, we know if it's rising or decreasing in value. Let's look at a real-world example. A ride at an amusement park rises 8 feet every horizontal change of 2 feet. So it's going up 8 feet every time it moves horizontally 2 feet. How would you determine the slope of the line? So what we're trying to say is, let's say, let me create here a white space area so you can see what we're talking about. What we're trying to say is that every 2 feet, so here's 1 foot, 2 feet, it's going to rise 8 feet. 1, 2, 3, 4, 5, 6, 7, 8. No, about that much. Okay. So we're saying that it's going to rise 8 feet, there we go, up to there, all the way to there, as it covers 2 feet. So you can see here that it went up all the way to 8, but horizontally it only moved 2 feet, right? So that's kind of what the slope would look like. That's what they mean. So going back to the question, how could you determine the slope of the rise? I'd say write a ratio of rise to run. So the rise is 8 to run is 2, or 8 feet to 2 feet, and simplify. So if it's 8 feet to every 2 feet, that means we're rising 4 feet to 1 foot, or we can just say we have a rise of 4 per unit, right? So it's rising at 4 feet per 1 foot horizontally. And here's what we just did, but now it's in words. So this is one of the key concepts. Find a slope using graph or table. Here we go. Slope is a rate of change. So how things are changing. It can be positive, slanting upward, or negative, slanting downward. Upward slant would be like this, downward slant would be going the other way. How do we determine slope? Well, through a ratio, as we've explained. You place the rise over the run. We did 8 over 2. Vertical change between any 2 spot points, horizontal change between the same 2 points. And that'll determine our slope. So example 1, here we have a treadmill. And on a treadmill, you can usually change the slope of the treadmill. It's not totally horizontally. You can put a little bit of an incline on it, which makes it seem like you're running uphill, and it makes it a little harder. The exercise will be more effective. So you have slope, rise over run. You have a rise of 10 inches. There it is, 10 inches over 48, a span of 48. So to simplify, you can simplify this ratio. They can both be cut in half. This would go down to a 5, and the 48 would go down to a 24. So 5 over 24. The slope of the treadmill is 5 over 24. And what does this mean? Well, we'll work with the graph to graph these. But here we have a y and an x coordinate. And so we place rise above and over run. Rise is our vertical axis, and run is our horizontal axis. So X is at the bottom and Y is on the top. Okay, so how would it work? We'll look at a graph in a minute and see. But before we do that, let's practice identifying the slope. Okay, and once we can identify the slope, then we'll graph. A hiking trail rises 6 feet for every horizontal change of 100 feet. So we've got 100 feet horizontally, right? 100 feet. And we have a rise of only 6 feet. A rise of about 6 feet. And obviously this is not to scale, but I just wanted to give you an idea that if this is going to be 100 feet, this little bit will be 6 feet, or even less than that, really. What is the slope of the hiking trail? Okay, we have a rise of 6 and a run of 100. If we simplify, I have 3 over 50. And that's as far as I can simplify it. And this is the ratio that we would use when graphing, 3 over 50. Now let's look at how to graph. Example 2. The graph shows the cost of muffins at a bake sale. Find the slope of the line. So here we have muffins purchased, okay, and the cost. So when one muffin is purchased, we see that it's $2. You see that? It meets at 2. 2 here is 1 here. 2 muffins are purchased, we have $4. 3 muffins are purchased, we have $3. We have $6. You see, $6. So 1 muffin is $2. We can see that. So choose 2 points on the line. The vertical change is 2 units and the horizontal change is 1 unit. Yeah, horizontal is 1 unit and vertical is 2. Slope is rise over run. That's the definition of slope, rise over run, which means 2, it'll rise 2 for every 1 horizontally. You see that? So the slope of the line is 2 to 1 or 2 to 1. So what we do is we always rise 2, or we run 1, rise 2, run 1, rise 2, run 1, rise 2, and continuing on, and then we connect all the dots, and that's how we get our line. This is also how we interpret a line. We see a line on a graph and we try to interpret its change, how it's changing in relation to the horizontal and the y-axis, right? And we see where the dots are plotted to make the straight line. But now let's see how we analyze information on a table. Something to note about our lines or our slope. A slope in linear relationships, no matter which 2 points you choose, the slope or rate of change of the line is always constant. So as I mentioned, we're going to now analyze the information on a table. The table shows the number of pages Garrett has left to read after a certain number of minutes. The points lie on a line. Find the slope of the line. So here's the time. He's got 1 minute. In 1 minute, he has 12 pages left. Then he reads for 2 more minutes to get to 3, and he has 9 pages left. Then he reads for 2 more minutes, he has 6 pages left. He reads for another 2 minutes, and he has 3 pages left. So it looks to me like every minute could be 1.5 pages. Well, we'll figure that out in a minute. So we have the slope is the change in y and the change in x. What we mean here is we can choose any change from 12 to 9, from 9 to 6, from 6 to 3, any of these changes. And the change in x from 1 to 3, from 2 to 5. So when we identify the changes, here we're going to do what's the change from 9 to 12 and what is the change from 3 to 1. Notice that we are keeping them in the same order. So you notice I took the second point and I'm going to subtract the first point as well. I've took the second point from my x and I'm going to subtract from the first point. So I'm keeping them in order. So it's 9 minus 12 and 3 minus 1. You can see that there. So now I have a negative 3 over 2, or just simply negative 3 over 2, which is negative 1.5. Correct? If you change it over to a mixed number. But we keep it like this. We're going to keep it as a negative rise number in a run, and you'll see why in a minute. To check, choose 2 different points on the table and find the slope. So again, we can choose any other 2 points. So now this time we're going to do the bottom. We're going to do 3 minus 6 and 7 minus 5, as you can see there. And we still get a negative number. Okay, negative. So it works. It's still a linear expression. So let's check here now. How would we graph that? Oh, here we have 2 examples, one graph and one table. Let's identify the information. If you feel confident doing it, go ahead and do B on your own, and then check my answers. So pause now. Okay, let's check. Here I have 1 point all the way here and another point there. And when I look at my horizontal, I see the difference between this point and this point as 1, 2, 3, 4. So I could say that my run is 4. And my rise, okay, from this point to this point, my rise has to be directly vertical, right? 1, 2, 3. I have a rise of 3. Okay, so there it is. My every time I move 4, every time I run 4, I'm going to rise 3. And that's, I'm going to rise 3. That's my slope. Another way to do it would be to identify the coordinates. So here, for example, for this point, what are my coordinates? Well, I have what, -2, right? -2 over -1, right? Or I could write it like this: -2x and -1 for y. That's my first coordinate. And then my next coordinate would be +2. Always horizontal first, 1, 2, and then 2. So I would go here 2 and 2. So now my slope equals my change in y and change in x. So remember, here are my x's. These are both my x's, the first 2 numbers, and there's my y. So why don't I go ahead and check the change in x and change in y? Let me replace those variables. I'm going to let S represent slope, right? And I need to do my change in y on the top. So change in y, here's my y. My change in y is going from a -1, and I'm looking for the difference, so I'm going to subtract the 2. So essentially what I'm doing here is -1 minus 2. And then change in x is going to be -2 minus 2. Okay? And when I do that, I check my slope, and I get -1 minus 2 is -3. And on the bottom I got -2 minus -2. So -2 minus 2 is going to be -4. And there we have it. Now this is negative divided by negative is still a positive, so this would equal the same as 3 over 4. And this would equal the same as 3 over 4. So, and now we can actually use this information to graph. So from either one of these points, okay, for example, from this point to this point, if I were going to go, I would have to move, run is -4, remember, bottom is the x, so I would go -4 is this way, positive is that way. So -4, I would move 4 to the left, 1, 2, 3, 4, and then -3, I have to move 3 down, 1, 2, 3. So you see, and if I go the other way, it would also work. Run 4, 1, 2, 3, 4, +3, 1, 2, 3. So they both work. And you just count again from the same point if you're going to go further up, or you would count from this point if you're going to go further down. Let's look at C now. We have our x's, which are all our denominators on our ratios, and our top number. Okay. So we can pick any 2 consecutive points and do check for change in y and change in x. We can do the first 2. So change in y to change in x. I see that. So I will do slope equals change in y. Here's my change in y. Minus, oh, I'm doing highlighter instead. -1 minus -2. you see that? Okay. And then for my x, I will do -2 minus -6. So you can see right there. Okay, when I do so, I will continue over here, and I have -1 minus -2 is like adding 2, so I'm going to have a 1. Okay, if I have -1 take away -2, it's going to be +1. This is like adding 2 to -1. And I have -2 add 6, or take away -6, it's going to be like adding 4. Oh, again, I chose the wrong one. Sorry. 4. So it's 1/4. That would be my slant. So since we know we have rise over run, for this graph, every time we move horizontally 4, we're going to move vertically 1. So every 4 is 1 up, 4 and 1 up. It's not going to be a great slope, nor a very steep slope. And for our next key concept, let's look at slope, the slope formula. In words, the slope, or we can use the variable m, of a line passing through points x, the first x and the first y coordinates, and the second x coordinate and the second y coordinate, is the ratio of the difference in the y coordinates to the corresponding difference in the x coordinates. So what we're saying is we're going to check how the difference from first x and the second x differ, and this first x and first y and second y change, as we were looking, change in x and change in y. As you can see here, change in y, change in x. Okay, where x2 cannot equal x1. They cannot equal each other, otherwise there's no slope, right? It would just be the same point, the same coordinate. And you can see there, it does not matter which point you define as x1 and y1 and x2 as y2, as long as you keep them uniform. So if you're going to use, doesn't matter which one of these two you use as x1 and x2, as long as you keep the same coordinates, okay, the pair together. However, the coordinates of both points must be used in the same order, of course. Example 4. Now this is what a typical question in this chapter will look like. We will be asked to find the slope of a line that passes through, and then we'll be given the points. So here we have coordinate point R and point S with the order pair 1, 2, and the order pair -4 and 3. As you can see, there's R and there's S. Okay, for S it went -4. See, it went 1, 2, 3, 4 to the left. Okay, and sorry, it should be down here. 1, 2, 3, 4, and then it went +3. 1, 2, 3. There it is. And for this one, 1, 2, it went over 1 and up 2. So now we have to find the difference between the two. So we look for the difference in y and the difference in x. Notice that this is y2 and x2, so we're going to use the same ones. And y2 would be this one, and x2 would be this one. Sorry, we're using the 2's first. So the 2's first would be right here, and the y's, the first y's and x would be right here. Okay, so make sure that you keep them uniform like that. And we identify that it's -1/5. Is that the slope? Well, let's see. -1/5. We run 5, -5, 1, 2, 3, 4, 5, and up 1. Or you could say we run down 1 and over 5, depending on which number you want to make negative, which doesn't matter. You can make the 1 negative or the 5 negative. Okay, let's try D and E. Okay, if you think you can do it, go ahead. Pause the video and try D and E and try to find the change in y and the change in x to identify the slope. Go ahead and pause the video now. Alright, so I hope you paused the video. Now let's look at D. For D, we're going to write S for slope. Okay? S equals. Now we want to do change in y and change in x. And the symbol for change is actually a triangle called delta. So change in y over change in x. And now we can assign here, which is going to be the 1's and the 2's. So I'm going to make these my x1 right here. This is my x1, and this is my x2. This is my y1 and my y2. Okay, so I'm going to now subtract it doesn't matter which one you subtract first, as long as you keep them separate. So if you want to subtract the ones from the twos, you can, or the twos from the ones, you can, as long as you do it uniformly. So we have S. So I'm going to subtract, I think I'm going to subtract the larger numbers from the smaller numbers. So I'll take x2, right, minus x1. Oh, not x's, sorry. I'll erase that. I meant to write white and y. y2 minus y1 over x2 minus x1. Okay, now we replace those variables where slope equals my y2 is 3 minus my y1 is 2. You can see here, there's one and there's the other. Okay, and then that's over my x2 is 5 minus my x1 is 2. And that's going to equal 1 over 3, right? So my rise is 1 and my run is 3. So that's my slope. If I run, I rise 1, I'll run 3 and I'll rise 1 each time. All right, now let's look at E, where we have, again, slope equals change in y over change in x, and we're going to have slope equals y1 minus y2 or y2 minus y1. It does not matter as long as we keep it uniformly. If you're going to put the twos first, put the twos first. Or y, it has to be the first one for the both y and x. So when I look at the numbers, I think I'm going to do, I'll just do y1 minus y2. And over here, I'm going to do x2 minus x1. Oh, no, it has to be the same uniformity. This is what I meant. You see, if I'm going to put y1 here, I have to put x1 here. Okay, I can't change it like this, because then I'm not going to get the right answer. So I have to erase this. It's good that I made that mistake so you could see what I was trying to say when I said uniformly. Now this has to be x1 minus x2, just the way it is on the top. Okay, now I can replace my variables. Remember, this right here is x1, and this is x2, this is y1, and this is y2. Okay, slope equals y1 is -4 minus y2 is -2. Okay. And that's over x1 being -7 minus -3. Okay. -4 minus 2, or take away -2. I'm going to take away 2 negatives from here. It becomes +2 essentially. But if I take away 2 negatives, I got to take away 2 negatives from this amount. It will become S equals, it will become -2 over, and then I have -7, take away 3 of those negatives, I'm going to have -4. Okay, which would be the same as saying a half, right? If I want -1 over -2. Now negative divided by negative is positive. So you can also, it would be the same thing as saying S equals 1 over 2. And that's my answer. Okay, and that's it for today, everyone. Here's your guided practice. Please look through the questions. Make sure that you become familiar with them, because this is how we will start next class. See you then, everyone.